The U.S. Space Force has just approved a plan to build 2 brand new launch pads for SpaceX's Starship. It's a huge milestone, one that points to an even busier future for the world's biggest rocket down in Florida. More interestingly, this move also marks the beginning of a new, more powerful Starship variant, a version designed to redefine the future of military operations and national security missions in space. So, what exactly is this new Starship, and why is it such a big deal for missions at the national level? Let's break it all down in today's episode of Alpha Tech. SLC-37, once a historic launch site for Saturn IB missions during the Apollo era in the 1960s, and later the home of ULA's Delta IV rockets from 2002 to 2024, was supposed to be left abandoned with no one to take care of it anymore. But instead, SpaceX stepped in, leased the site, and is now not only bringing this legendary launch complex back to life, but also turning it into a place that could create a whole new chapter of Starship history in the years ahead. Right after securing the lease, SpaceX began tearing down ULA's old towers in June. Nearly 6 months have passed since then, and the area has been completely cleared out. Even better, the final environmental impact statement has just been approved following the earlier draft, officially clearing the way for construction to begin immediately. All these smooth steps forward were made possible thanks to major support from the U.S. Air Force Space Launch Delta, 45, and several other agencies. On X, SpaceX celebrated by posting, "We've received approval to develop Space Launch Complex 37 for Starship operations at Cape Canaveral Space Force Station. Construction has started." They also expressed their appreciation, adding, "With 3 launch pads in Florida, Starship will be ready to support America's national security and Artemis goals as the world's premier spaceport continues to evolve toward airport-like operations." As the head of SpaceX, Elon Musk couldn't stay silent either. He said, "Congrats SpaceX team, and thank you US Space Force." The way he said it felt more like a casual shout-out to an old friend, which makes you wonder, why is everything going so smoothly? Normally, approvals like this are not supposed to be this easy. Take ULA's Vulcan Centaur at SLC-41, for example. Even though the environmental assessment was completed back in 2019, the entire certification process for national security missions dragged on for more than 5 years. Or look at Blue Origin in 2013, when they sued NASA over the leasing process for LC-39A, claiming it unfairly favored SpaceX and demanding exclusive rights. That lawsuit lasted 3 months, and Blue Origin still lost. SpaceX got LC-39A in 2014, while Blue Origin had to move over to LC-36, spending several more years building their pad, ultimately delaying New Glenn all the way to 2025. But there's no favoritism here, and no behind-the-scenes connections at play. SpaceX earns these wins by capability. Years ago, they proved themselves with Falcon 9. And today, even though Starship hasn't fully succeeded yet, it's only a matter of time, and everyone knows it. Part of this fast-track approval also comes from something that happened back in 2022, when SpaceX received a 5-year, $102 million contract from the U.S. Space Force to develop the rocket cargo program. The idea is to use Starship as a rapid global transport vehicle, capable of delivering hundreds of tons of military supplies to any point on Earth in under an hour. Basically, a space-based logistics system for sensitive or high-risk missions. By November 2024, the Space Force was closely tracking Starship's test flights, calling it a potential game-changer for deploying large satellites to low Earth orbit or moving military cargo quickly. They saw a clear path toward future national security certification, and they were thrilled by SpaceX's steady progress. From 2 back-to-back successful Super Heavy landings on Flights 7 and 8 to returning Starship safely from the harsh conditions of space on Flights 10 and 11. All of that laid the groundwork for this early approval. And here's the important part. SLC-37 is managed directly by the U.S. Space Force, not NASA. That alone tells us something. Beyond expanding launch capacity, SpaceX is very likely preparing to develop a military Starship variant right here. So, what exactly is the Starship variant being planned for SLC-37? I should say this up front, none of this is made up. The draft environmental impact statement itself reveals that this version is going to be an absolute giant. According to the document, The Starship upper stage would stand about 230 feet tall, or roughly 70 meters, while the Super Heavy booster would reach 263 feet, about 80 meters. Combined, the full stack would stretch to a staggering 493 feet, or 150 meters. That's even taller than the Starship version 4 that Elon Musk mentioned during a presentation at Starbase, a version expected to be around 142 meters tall. But the draft also uses the word expected, not confirmed, so nothing is final yet. It's entirely possible that SpaceX could adapt the Starship version 4 configuration and turn that into the military variant instead. The upgrades for this variant don't stop at size. Its propellant capacity is getting a massive expansion. The ship itself would carry about 2,650 tons of fuel, while the Super Heavy booster would hold 4,100 tons. This increase gives the vehicle far greater range and mission flexibility. When it comes to engine power, the improvements are just as dramatic. The Super Heavy booster will still use 35 Raptor 3 engines, but the ship is expected to jump from 6 to 9 engines, 3 sea-level Raptors and 6 vacuum Raptors. Each Raptor 3 stands roughly 10 feet tall with a diameter of 4 feet. These engines are capable of producing 280 tons of thrust at sea level and 306 tons in vacuum. That means the Super Heavy booster alone would generate more than 103 meganewtons, or over 10,500 tons of thrust, while the ship adds another 28 meganewtons, roughly 2,800 tons. These numbers represent a huge leap compared to the current Starship configurations. Both stages will continue using stainless steel as their primary structural material, a choice that aligns perfectly with SpaceX's long-standing preference for its low cost, high durability, ease of manufacturing, and suitability for rapid refurbishment. In short, the Starship variant planned for SLC-37 is bigger and more powerful than anything being developed at Starbase, or LC-39A. And honestly, that makes perfect sense. The military wants a vehicle that can maximize payload capacity and mission range, essentially turning it into a multi-role space super truck for high-stakes operations. And because it can fly globally in under an hour, imagine a real scenario. A sudden crisis at Diego Garcia, one of America's most secretive and strategically critical bases in the Indian Ocean. In a moment like that, the U.S. might need to deploy missile defense systems medical supplies or even special operations units immediately to a contested island. Instead of relying on slow, vulnerable cargo aircraft, Starship could deliver everything in a single shot, flipping the situation on its head in a matter of minutes. On top of that, this variant would also support deploying large satellites for the Starshield intelligence network, things like launching clusters of high-resolution spy satellites to monitor adversary activity from orbit, or reinforcing military GPS and communication constellations to make sure they never go offline. Its importance to U.S. national security is hard to overstate. Not only could it slash military logistics costs by orders of magnitude thanks to full reusability, recent reports show the U.S. Space Force spending about $1.8 billion for 11 NSSL launches in 2025, down from roughly $2.4 billion for 15 launches the year before. But imagine if they relied primarily on Starship. The cost could drop to somewhere around $200 to $300 million, since a Starship flight is projected to be as low as $10 million per mission, with most of the price coming from additional service fees rather than the rocket itself. But beyond cost, it's the strategic edge that truly matters. Starship gives the U.S. the ability to respond asymmetrically to threats from China or Russia, whether that's protecting critical satellite infrastructure or conducting global point-to-point missions that traditional aircraft simply can't match. It strengthens America's position as the leading space superpower in an increasingly tense geopolitical landscape, while pushing deeper public-private collaboration to shape the future of space exploration. That puts operational readiness somewhere around mid to late 2027 or possibly early 2028. To hit that target, SpaceX might begin building and testing those 150-meter or 142-meter prototypes a bit earlier, so they're ready the moment the new launch complex goes online. And that timeline lines up perfectly with the completion of the Gigabay factory at Starbase, which is expected to support the first wave of prototype production before shipments begin heading to Florida. So, are you excited to see this giant new version of Starship come to life? If you are, drop a Go Starship in the comments below. But no matter how exciting this project sounds, none of it means anything if it can't work in the real world, right? And that's where things get tricky. So far, every Starship variant described in official documents has no landing legs and relies entirely on a catch system for recovery. That's fine in a controlled environment like Starbase, but Earth-to-Earth transport is a completely different game. It would require Starship to land in all kinds of conditions, from fixed landing pads near major cities to unprepared terrain during emergency military missions. With that in mind, maybe SpaceX needs to rethink the no-legs approach. The current crane-style catch system, the launch tower with those giant chopstick arms, is great for fixed sites like Starbase, or the new pads coming to Florida. It saves weight, speeds up reuse, and works beautifully when everything is built around it. But for point-to-point missions, where Starship might need to land at dozens of locations around the planet, building a catch tower everywhere is just unrealistic. The logistics alone would be insane. In that case, adding landing legs to the upper stage, similar to Falcon 9, could be the more practical solution. That would allow Starship to touch down on mobile pads or even semi-prepared surfaces. Exactly the kind of thing the U.S. Air Force has been studying for rapid cargo missions to remote places like Johnston Atoll. Of course, SpaceX would then have to trade the weight penalty of landing legs against global flexibility. A hybrid approach might actually be the sweet spot. Use the catch system for domestic flights near home base and deploy landing leg variants for long-range international missions. That's a decision they may have to confront sooner rather than later. In the meantime, SpaceX still has to master the core flight operations of Starship: launch, staging, payload deployment, engine relights, atmospheric re-entry, and landing. Getting all of these right is essential, not just for long-term goals, but for the very next test flights. Recent missions have exposed a few weaknesses, especially during the return phase. Fixing those will be a top priority as they head into the next integrated flight test, Flight 12, which is expected soon. SpaceX is truly shaking up the entire aerospace industry. While other companies might take a decade just to roll out a single upgrade, Starship is evolving at a breakneck pace. Almost every year, a completely new version appears, bigger, stronger, and more optimized. For example, 2025 marked the era of Starship version 2. That chapter has now closed, and the company is gearing up for an even bigger leap with Starship version 3 in 2026. This will be SpaceX's largest upgrade yet, focusing on increased height, more powerful engines, and full reusability. According to SpaceX and Elon Musk, V3 is designed to carry up to 200 tons to low Earth orbit in reusable mode, and roughly 300 tons if expendable. Fully stacked, the two-stage vehicle reaches a total height of 124.1 meters, slightly taller than the previous version, but still holding the record as the largest rocket ever built. Impressive as that is, will this record hold now that Blue Origin has just revealed an upgrade that could surpass even Starship V3? Just a few days ago, the company posted an update on X that stirred up quite a bit of attention, saying, "Starting with NG3, we will phase in a series of upgrades to the New Glenn launch system designed to increase payload performance, launch cadence, and enhance reliability," along with a link to a more detailed breakdown of those upgrades. To be more specific, the website linked in that post talks about what is essentially a new version of New Glenn. Let's call it New Glenn 9x4. Basically, those numbers mean the booster stage will get 2 additional engines, bringing the total to 9, and the second stage will jump from 2 engines to 4. That's a pretty big leap compared to the current 7x2 setup. And if you compare the scale to Starship version 3, this design really does look like an upgrade. Starship V3 mainly moves from Raptor 2 to Raptor 3 engines, but the engine count stays the same. Here, Blue Origin is increasing the number of engines, stretching the overall length, and of course, enlarging the fuel tanks as well. But is simply adding more engines enough to beat Starship? Definitely not, because with Starship, every upgrade is a massive leap forward. Take Super Heavy as an example. In version 2, it had 33 Raptor 2 engines pushing around 7,500 tons of thrust, or let's switch units, about 16.5 million pounds of thrust, earning the title of the world's most powerful booster. But after the upgrade to 33 Raptor 3 engines, The thrust jumped to an insane 18.7 to 19.8 million pounds in Phase 1. And that's just the booster. The Starship V3 upper stage, with its 6 Raptor 3 engines, produces roughly 3.3 million pounds of thrust in Phase 2, helping the full stack reach about 200 tons to LEO. That number alone puts it far ahead of New Glenn. Even with the upgrade, New Glenn doesn't look particularly impressive. As CEO Dave Limp himself said, the total thrust on the booster is increasing from 3.9 million lbf to 4.5 million lbf. Total thrust on our 2 BE3U engines is increasing from 320,000 pounds force to 400,000 pounds force over the next few missions. Those numbers only allow their upper stage to carry a maximum of about 70 tons to LEO in an expendable configuration, a little over 20 tons to lunar transfer orbit, and roughly 14 tons directly to geostationary orbit. In other words, even with all these upgrades, their rocket is still only about 1/3 as powerful as Starship. But if Blue Origin wants to compare the New Glenn 9x4 to the Saturn V, well, that might actually be fair. Dave Limp even posted a comparison on X, and here's the visual to make it clearer. Right in the middle, you've got the Saturn V, the legendary Apollo-era rocket, standing at 110 meters tall, yet it's still shorter than the New Glenn 9x4. Even though Blue Origin hasn't officially released the height, the comparison makes it pretty obvious. It seems to stand roughly in the same range as Starship, about 120 to 123 meters. When fully stacked, it's only about a meter shorter than Starship. Pretty impressive, right? It's almost like watching a size contest between Elon Musk and Jeff Bezos, and, well, you already know who loses that one. Now let's dig a little deeper into the numbers. Along with the increased thrust and higher payload capacity, the 9x4 variant will also feature a payload fairing wider than 8.7 meters, making it one of the largest commercial launch vehicles ever built. This expanded fairing gives customers the freedom to launch massive satellites and spacecraft that can take advantage of nearly the entire diameter of the rocket. Blue Origin has already confirmed that Mix 2 was specifically designed to fly fully unfolded inside the New Glenn 9x4 fairing. No folding legs, no complicated mechanisms like MK1 squeezing inside the old 7-meter fairing of the 7x2. Just a clean fit with plenty of room to spare. This puts New Glenn in the same heavy lift category as SpaceX's 9-meter Starship, giving customers 2 competing options for launching ultra-wide payloads, reducing risk, and preventing dependency on a single provider. But let's be honest, if you're a customer trying to launch a rover to Mars, you're going to choose the cheaper and safer option, right? Based on SpaceX's published pricing, sending a 3-ton rover on Starship costs roughly $300 million per launch. With New Glenn, you'd be paying about 1.5 times that, and Starship can deliver nearly double the payload of New Glenn. Of course, competition is healthy, especially now that space is becoming more commercialized. And to stay competitive with Starship, Blue Origin's redesign heavily emphasizes reusability and fast turnaround times. The first stage and the payload fairing of the 9x4 will be fully reusable, and the booster will feature an upgraded heat shield with next-generation tiles and backup layers designed to reduce maintenance between flights. Thanks to the iterative design work already proven on the 7x2, the 9x4 can be developed more quickly and flown more frequently, setting the stage for a much higher launch cadence. And this reusability isn't just a technical upgrade, it's a massive cost advantage. Blue Origin is targeting a launch cost of under 1/10 of NASA's $2.2 billion SLS, aiming to bring New Glenn flights below $220 million each. While the upper stage won't be reusable, it's being redesigned with a simpler, cheaper structure to cut production costs. Alongside that, Blue Origin is making several performance-boosting upgrades. The 9x4's second stage is significantly lengthened for greater propellant capacity, and, taking a page from SpaceX, they're adopting subcooled cryogenic propellants to increase fuel density and engine efficiency. In short, New Glenn 9x4 represents a transformational leap forward for Blue Origin. After looking at all these numbers and upgrades, which one do you think is more impressive, New Glenn or Starship? Drop the name of your favorite down in the comments, and let's see which side wins. And there's still one more big difference we haven't talked about. Beyond raw power, The real split between Starship and the New Glenn, 9x4, comes down to how many engines each rocket uses and what that says about their entire design philosophy. Starship version 3 is expected to fly with a staggering 39 Raptor engines, 33 on the Super Heavy booster, and 6 on the upper stage. Meanwhile, New Glenn 9x4 uses just 13 engines total, 9 BE4s on the first stage and 4 BE3Us on the second. That gap isn't just about thrust. It represents two completely opposite approaches to modern rocket engineering. SpaceX follows a many small engines philosophy, using engine count as a core strategy to boost reliability and scalability, pushing back against the old belief that more engines equal more complexity. Elon Musk and the team argue that having a large cluster doesn't make the rocket harder to manage. In fact, it simplifies development and operations. First, there's redundancy. With 33 engines on the booster, Starship can survive multiple engine failures without losing the mission. If 3 to 5 engines fail during liftoff, the flight software can automatically compensate, keeping the rocket stable. We've already seen this in test flights where Starship continued flying smoothly even when several Raptors had issues. Second, this philosophy supports rapid iteration and mass production. Each Raptor is smaller and easier to build than a single giant engine. That lets SpaceX manufacture hundreds of them every year, with costs dropping as production scales. Musk always says, the best part is no part. But when it comes to engines, more units actually reduce design risk. You can upgrade or troubleshoot individual engines without halting the entire program. And finally, the high engine count makes the architecture extremely flexible. SpaceX can scale thrust simply by adding or removing engines, enabling different Starship variants for Earth, the Moon, or Mars without redesigning the whole system. Blue Origin, on the other hand, takes the opposite approach: fewer, larger engines to minimize potential failure points. It's a more conservative, traditional strategy that emphasizes durability and reliability of each engine rather than redundancy through quantity. Of course, no matter how you compare them, SpaceX still has the edge. It's the world's leading private space company, and its role in the future of spaceflight may even surpass NASA's in some areas. But if we're going to call Blue Origin a real competitor, then we also have to acknowledge what they've achieved. New Glenn, New Shepard, Blue Ring, the lunar lander. These aren't small accomplishments. All of that progress comes from a strategic leadership overhaul engineered by Jeff Bezos and the bold vision of the man he handed the controls to, Dave Limp. When Bezos brought Limp over from Amazon, it wasn't a random hire. It was a calculated move to inject new energy and discipline into a company that, despite billions in annual funding, had grown slow and complacent under former CEO Bob Smith. Blue Origin has always had the money, talent, and ambition. What it lacked was the urgency and execution to compete with the breakneck speed of SpaceX. At Amazon, Limp oversaw some of the company's most complex operations, from massive global logistics networks to AI-driven robotics handling millions of packages daily. That kind of efficiency is exactly what Blue Origin needed. Under his leadership, the company has embraced Amazon-style principles: scale fast, scale smart, and tighten every workflow. Instead of building a handful of test vehicles, Blue Origin is now developing the capacity to produce and launch rockets in higher volume, faster, and reliably. Limp's nearly 2 years at the helm have been defined by industrial expansion, tighter timelines, and a culture of accountability.